Well, a little bit of math goes a long way in Grasshopper, and I thought after this entire massive strip I built right here going through the first chapter of calculus, single variable calculus, I thought, well, why don't we apply one simple script? And we're using the quadratic and solving for plus or minus y or x or whatever you want to call it on a simple grid. And I've done that. There's my two-dimensional grid I've been using up until this date. And you'll notice these wonderful lines that have been extruded here in the z direction. All I'm doing is pushing the geometries I've been making into the z direction, and you'll see that this stems solely from a little bit of funk in the z direction through a range that if I brought that back down, you'd recognize this original form. It's just a circle on a grid. That's all it is. And the rest of it's just this extrusion and an enviromap to show you the perfect forms that you can achieve from a little bit of math. So all I'm doing is throwing to a range and generating these parametric shapes that I think are just fantastic. Keeping the step to 1, it doesn't have to be tricky at all. Once you start to play with the steps, you start to get some real gangly wrinkling of forms. And you start to get some distortion, which is also the power of working in Grasshopper parametrically as well. But I'll set that one off to 1. And then my multiplier here is just a little bit to extend it in the let's see, y-x direction. And that's it. I can bake it as a bunch of different shapes. All I did was my same old mirroring of a couple of curves. If I took this off and you see what I'm generating, basically I have a plane that I'm taking those original forms. I'm lofting them together. I'm doing a simple point extrusion from points on surface, moving them out. And of course, I can move them out on any layer. I mean, I can really balloon this thing up, right? Like that, you start getting some wonderful forms. And then I'm using my age-old trick of just going in and de-brepping and grabbing the curved surfaces and lofting them together to get one closed, perfect geometry to bake into Rhino. But this entire script is based on the quadratic equation, which solves for x, a, b, and c through this equation, and then simply taking those points and having fun with them in both directions. I think I had some lines here to look at, but otherwise, pretty simple stuff from the start to finish. And if we throw it back on, you can see the really tight, clean geometry and calculus that drives this, and a little bit in the z direction, and bam, you're a product designer. You're an automotive dealer. You're making napkins for a wedding that people can take the middle sculpture home on their tabletop. Wherever the imagination goes, it's taken me 3 years to get a computational mind on the computer, which I think I had always in building sculpture and Adobe and casting and doing all these projects in my life. But coming back to this, coming back to where I was, looking thirsty for the visuals of what's actually happening here, you could just see the power of producing wonderful designs. And as a sculpture instructor, you see all the venues of where this can actually go if somebody really wants to push their mind towards it. Michael Wickerson, Wickerson Studios, always out for contract. You come on and grab my GitHub files through my repository at Patreon. You can walk away with, for $3 a month, you can walk away with this entire script. And I must admit, the blue will be where I'm applying a little bit of fancy pants Wickerson stuff at the end. I doubt very much I'll put the Wickerson nodes on because I don't mind sharing the age-old, millennium old, 2.5 millennium old formulas. But to have the visualization, know what you want to do with it, well, I'll leave that up to you. So for everybody out there that loves Grasshopper to work and change their static modeling in Rhino into something parametric and something computational, a little bit of math goes a long, long, long way. Thanks for watching.